Most people just see a black screen and wait. But have you ever wondered what's actually happening behind the darkness? The moment you hit power button, what is happening? How is your operating system loading? How is a cold piece of silicon suddenly loading an entire operating system? How is this all of these things happening? Is it a magic? Obviously not. It's not a magic. It's a high speed relay race. Today I'm breaking down just these 5 simple steps that takes your PC from a dead box to a live system. If you want to truly understand the machine you're using, you need to know this process. It's simple, very, very simple. So let's get into it. So today I learned inside a computer system. First, let's go through the introduction. So, before protecting any system or before attacking any system, we first need to understand what does a system do. We need to understand what is really happening within a system. Trying to defend what you don't understand is like defending a castle you have never seen. So, we'll explore our castle, we'll learn what it is, we'll learn its building blocks, how they are connected. So, let's begin. Check this. So, inside a computer system, so these are the components we have. So now let's start with the view side. That is practical. Okay, click on the component to discover what it does. Complete all A to unlock. Okay, let's click on the motherboard. What role does the motherboard play in a computer? It connects and allows communication between all the components. Yep, this is the answer. I'm good. So motherboard, it's like our, as it mentioned, the skeletal and nerves. It is used for communication between various components. CPUs have multiple cores. Okay, the modern ones have multiple cores that handle instructions in parallel, which help in faster processing of the task. This is a CPU. Next we'll go. Next we'll see a RAM. RAM is nothing but a random access memory. So it's for data temporarily while the computer is running. RAM stores the data temporarily. So RAM is comparable to our brain's short-term memory. When working on a task, we keep relevant information in mind. Random access memory or a RAM does the same. It holds the data that the CPU needs quick access to. RAM is volatile. When power is lost, all contents are gone. Boom. This is all about RAM, and this is how RAM looks like. Next we have the storage. Obviously SSDs and HDDs, these are storage used for long term memory. If RAM is for the short term, then we need something to store for the long term, which is a SSD and HDD. Yes, so this is the answer and I'm good with it. So they are the storage device. They are like our long term memory. HDDs use older technologies with moving parts and they have very limiting performance, whereas SSDs, they have no moving parts. So you use memory chips, SS and HDD. HDD is low cost and have larger capacity. So when we press the power button on our computer system, first what happens is a signal. A signal is sent to the PSU to allow power to flow. Yes, simple. PSU is used for power supply. So when we press the power button, a signal is sent to the PSU. Then PSU starts supplying power to the components. Next is the firmware start. Step 2, firmware start. Now we have something called Unified Extensible Firmware Interface, which help in the firmware start. Have you heard of BIOS? I think BIOS is the most commonly used term. Basic input output. It's a boot firmware. Similarly, UEFI, Unified Extensible Firmware Interface, similar to BIOS. So a computer system contains a firmware that allows all its components to start up. So the work of firmware is to, after power supply, it will starting up the components or waking up the components. After waking up, power on self-test. While waking up, what happens? The UEFI, it will check if the component it is waking up is in its correct state, if it's configured correctly, if it is functioning, then it will wake it up. If it is not, if they are not working or configured correctly, then it will give us an error. That is the power on self-test. That is the testing the components being woken up. Next, you have select boot device. Once everything is done, all the components are up. Now what happens is the UEFI, it has an ordered list of which prioritize. It has an ordered list. Now UEFI, it has an ordered list which prioritize on which device to look first for the boot up routine for the operating system. So it will select the device which has to be booted up for the operating system. That is a select the boot device. Finally, initialize. Finally, we have the step 5, which is initiate the bootloader. Now we have selected, we have to boot up the which operating system to boot up. UEFI selected which operating system to boot up. Once selected, bootloader is initiated. Bootloader, what it does is it pulls the operating system from the UEFI and then transfer it to the RAM, random access memory. Once it is on the RAM, it starts booting up. It starts reflecting on our system. And once OS is transferred, UEFI gives control over the different components to the OS. This is a really simple thing. Now let's view the site. I have to reset it. Okay, now let's view site. So we have to see what happens when you press the power button. The PSU starts delivering power to the components. Simple. What is UEFI's role in boot process? It initiates and coordinates hardware components. What is a post? Post is this thing, power on self-test. So whether the required hardware is present and working. This is the work of the post. Select the boot device. Who does this? UEFI based on the boot priority list. Next we have initiate bootloader. What does the bootloader do? Bootloader loads the operating system into RAM. Yeah. So now we have to order this. So first we have to press the power button. Let's drag this here. After I press the power button, what happens is firmware start. It checks the hardware components and the components. After this, power on self-test. After this, select the boot device based on the ordered priority list. Boot device is selected. Then the bootloader sends the booted operating system into the RAM. The bootloader loads the operating system into the RAM. Let's check the order. Oh yeah, so I got it. Now let's paste it. Okay, so that's all. Next is concluding. We have discovered core components of computer, how it boots. Now next we will be doing the computer types room. Let's do it. That was about SSD and HDD. Next we'll go to network adapters. To communicate with other computers and the networks, we use the network adapters. The network adapters contains the MAC address of our computer. MAC address is the media access control. Just like we use our vocal codes to communicate with our environments, a network adapter lets computers communicate with other systems. Network adapters come in a wireless and wired variants. They are embedded in the motherboard. They can also be added to the expansion cards. They are connected via the PCI Express ports. Next is a power supply unit. This is used to supply power to various components or all the components in a computer system. This is a power PSU. This is how PSU looks like. So that's why it is called the heart and lungs. It supplies the power to every components. Graphic card is used for processing and outputting visual information to display. It is used for faster processing. It does a faster processing compared to CPU, but it is not an independent entity. It has to be connected or it has to work with CPU in order to efficiently work. And it has multiple cores. Billions of cores are present in this GPUs, which makes it faster than the CPUs. Next is the input output. To send and receive data from the computers, so like when you click on the keyboard that goes to your system, it's an input, and what displays is the output. The monitor is the output. That's all about the input. Now we'll continue to the next session, which is the inspection. Okay, so we have to inspect. So this is for the input output. The monitor, keyboard, all are plugged in here. Then we have this thing, this for power supply units, connector for the PSU. It provides power to the motherboard and many other components. Then we have this one, SSDs and HDDs are attached here. Then we have this one for the graphic card or network card. Then we have this one for the network card and other expansion cards. Again, this for graphic cards and network cards. And then this is used for graphic cards, but also can host other high bandwidth cards. And then let's slowly go here. This is for the CPU. It is used to hold a CPU chip. Then this one is used to hold the RAM. So this is all about the motherboard, and these are the components. This is about the motherboard. So let's start the exercise. Okay, now we have to place where all of these components fit. Input output is here. Power supply, as we know, it was here. Storage, and then this here. Network adapter, I think it's in the middle. Graphic card is, it can be either here, either here. I place it here. And RAM, I'm gonna place it here. I think network card can also be here. Okay, let's place it there. CPU is here, CPU chip, and now I think we are done. Let's verify, and yeah, we got it. Yeah, so we're good. Now let's I'll just do a trial error. Okay, let me just keep the network adapter here, graphic card here. Let's see if it works. No, so network card has to be here itself. So let's rearrange it properly. Yeah, now let's see. Yeah, so graphic card can be either here, here, or here, but network card has to be here itself, and rest all has to be in the same place where I have kept them. So this is all about. Now let's go to, so what happens when you press the power button?